All right, so we're doing some Q&A to get ready for our trimester test tomorrow. So I have the study guide here, and then somebody just asked a question that was on your quiz for geometry a while ago, so I'm going to use some graph paper here and make it big so that we can all see. This might be something good to put on your study guide somewhere, or just take notes because the test is open note tomorrow. So whatever you have on paper, you can use. Do you have to use graph paper? No, not at all. I just happen to have graph paper here. So this won't be the exact same problem because I can't quite remember what the exact same problem was, the dimensions were. So basically the rest of class today is just, I'm going to just field as many questions as you guys have. And anything that you want help filling in on your study guide, I can help you with that. Not too shabby here. It's looking pretty good. Okay, so if you remember back, this problem said that there was like a box with cans in it, and we wanted to know the area that is not filled by the cans, basically the wasted space around the cans. And so if I were to just shade it in, it would be all this stuff, okay, that's all around the cans. And let's, for the sake of this problem, just say that this is 12 inches from here to here, and this will be 16 inches. Okay, well, in this case, we're going to find the area of the rectangle and then subtract out the area of the circles. So finding the area of the rectangle is going to be very straightforward. 12 times 16 is 192. Now we're going to do some work to find the area of the circles. If this whole distance is 12 inches and there's 3 cans across, that means the diameter of each can is going to be 4, okay? So this is 4 inches, and every single can is the same size. Now we need to find the area of one can and then multiply it by 12. Well, if the diameter is 4, so we'll do area is equal to pi r squared. We can't use the diameter, we have to use the radius. So we're going to do 2 here. Okay, so I'm going to use 3.14 for pi. So 2 times 2 times 3.14. So I find the area of one can is 12 56/100 inches squared. Actually, I don't think you're supposed to put that. Since I found the area of one, now let's multiply it by the 12 cans that we have. So I'm getting that the area of all 12 cans is 150 72/100 inches squared. Okay, so here's the area of my rectangle. I'm going to subtract out the area of my cans. And I get that the remaining area is 41 28/100 inches squared. Of course, on a test, I'd have you answer that in a complete sentence. Okay, that is a great complex area problem. Yeah, Aiden.
So when
If you do that, you're going to be squaring pi. You don't want to square pi, you only want to square the radius. That's why when I'm using a 4-function calculator, I always do the squaring part first. Just whatever it is, like if it was 6 squared, or if it was pi and the radius was 6, I would do 6 times 6, that's 6 squared right there, then times pi. Okay? That's a very common error, that's a good one to bring up. Okay, let's look back at our study guide here. Are there any parts of the study guide where you're not sure what to put, you're not sure of a formula, you want to see an example for? This is linked in Otis lessons. I'll give you a minute to look through it. There's also the back side too. Yes, ma'am.
Surface area of a triangle divided by 4.
Surface area of triangular prisms.
Yeah, and then there's like a hole.
Yeah, like a hole in the door. Like a door hole for that. Okay, yeah, absolutely. So let's go ahead and I'll do this again on graph paper. It's just so much easier because these boxes are small. But this is going to be surface area, and actually it's kind of more of like a complex surface area problem when it has a cutout like that. So let's come back to the graph paper so we have plenty of room. So let's say that we have like a tent. Okay. And then let's put a little door in it here. Okay, so let's assume that this tent is a triangular prism, and we would like to find out how much material, how many square feet of material we're going to need for this. We're also going to assume that there is material on the bottom of the tent as well. Okay, so let's say that this tent is 12 feet. The sides of the tent here are 6 feet and 6 feet. And the length of the bottom of the tent here is 8 feet. And our door is going to be 3 feet by 4 feet. So that's kind of a small door. Okay. And let's also assume it's going to be hard. There's a lot of things going on in this picture. But let's assume, I'll do it over here instead of on my triangle, that the height of this triangular prism, we'll say is 5 feet. Okay. So what I would like to do is I would like to find the whole surface of the area, or surface area of the triangular prism before I deal with our little door here. What's the area of the door going to be? Just say it out. 12. Okay. So after we do all of our math, we need to make sure that we subtract out 12 because we don't need fabric over the door. Okay. Well, let's go through and do our triangles first. And I love to make a list when I'm doing surface area. I know that there are all kinds of fancy formulas and things like that, but if you can just understand that it's simply the area of every side, you're going to do well. Okay. Well, we're going to do the triangles first, and the height is actually over here. It's 5 feet. So this triangle has a base of 8 and a height of 5. And remember, with a triangle, we're going to divide it by 2. So it's 1/2 times the base times the height. So the base is 8, so 8 times 5, and then divide it by 2, and I get 20. So I have the triangle in the front is 20, and the triangle in the back that we cannot see is 20. Now we need to do, yes sir?
So technically, since there is a front and a back to it, couldn't you take the front
Mm-hmm.
and just, because it's basically equal to squares, you take both those triangles and put them together, so couldn't
Yes.
you just not divide it and then you get 4 from the front and
Mhm.
back?
Just don't forget that you only need to do it once then. Because a lot of people make that logical connection, but then they accidentally add it twice. So don't forget if you're going to do that. Okay, so let's take a look here at the rectangles now. The one that we can see and the one that's in the back here, they're both 12 by 6. So 12 times 6 is 72. So that's the rectangle that we can see and the rectangle that's in the back. And now we just need to do the rectangle that's on the bottom here. So the bottom is 8 by 12 because it will be the same length here and here. Okay, so 8 times 12 is 96. Okay, let's just add this all up and then we'll take out the area of our door. So I'm going to add all these together. Okay, and I'm going to get 280 feet squared for the surface area of my triangular prism. And then I'm going to subtract out the area of my door, which we already decided was 12 feet squared. So the amount of fabric that you are going to need for this is going to be 268 squared feet of fabric. And if this was a word problem on a test, I would want you to answer in a complete sentence. Yes, Shauna? Angle word problems? No, I think it will be a picture, basically, of each. Yeah, so all of the angles that are on the back side, you'll be given a word problem, or not a word problem. You will be given like a picture. Yeah. Okay. Anything else you want me to go over from the study guide? What about exterior angle theorem? How you guys doing with that? You're good. Would anyone like me to do an example of exterior angle theorem? Yeah? Okay. And the Kahoot was fun. It was kind of the basic stuff. So just remember that, make sure you know how to do the other stuff as well. Okay. Okay. So if you remember back to when we did this, the exterior angle theorem says that the sum of the two remote interior angles is equal to the exterior angle. So you can use that to set up an equation. So you'll have 80 plus x is equal to 2x. And if we get all of our variables onto the same side, so I subtract x from both sides, I find that x is 80 degrees, which means that this angle is going to be 80 degrees, and this angle is going to be 160 degrees. Okay? So just don't forget that, the sum of those two interior angles is equal to the exterior angle. Anything else you'd like to go over? Any formulas you want me to help you get onto your sheet? Yeah, Shauna. Angle similarity theorem. Fantastic. Let's take a look at that. Okay. It's on your study guide right here. And I know that this is here, but I am not going to test you on this because we did the quiz on that on Wednesday. Yeah, absolutely. It's open notes, so whatever you have in your binder, you can use. Okay. Okay, we'll do some with some math involved and some with just kind of more theoretical. Okay, let's give this a name. Okay. So angle-angle similarity says that if two of the angles of a triangle are congruent, we can assume that those triangles are similar and that all those angles are congruent. Okay, so I can already see that I have two sets of congruent angles here and here because right angles have the same measure. So we can say that angle B is congruent to angle E, and that is because they are both right angles. Okay. I do like to think in the form of a table, so you don't have to do it in a table necessarily, but that's just how I think about it. Yeah, Shauna? Yeah, I just didn't because it's not necessary. There's no other angle E in this picture. That's the only angle that can be angle E. But when you get to angle C here, you can't just say angle C is congruent to angle C. You have to be specific. So these are vertical angles right here, so we can assume that they're congruent. So that means that angle ACB is congruent to angle DCE, and we can say that that's true because it's vertical angles. Okay, Bam.
Could you if you were to write angle A, could you just leave it angle A?
Yeah, yeah, because there's only one angle A there. There's no other angles coming off of that in that case, in that picture. Yeah, Shauna.
You only have two statements
You only need to prove that two are congruent. And then you can say, here's your similarity statement. You can say that triangle ABC is similar, not congruent to. A lot of people put congruent to or equal to. They're not. We can only prove that they're similar. Similar to DEC. And that is because of the angle-angle similarity. Okay. Yeah, Shauna. Yeah, it's fine. All right. Well, you guys are just about out of time. I will be here during nutrition break. I will be here after school. Come in and see me anytime you need me.